Okay, so this is the displacement, that is integration of dx from xi to xi. Now this we are going to write in the form of velocity. Hopefully you have the diagram and all from the previous class, right? We divided that whole displacement from A to B into so many small parts, correct? And first displacement, for example, was dx1 in a time interval dt1 and so on. So I can say that because always velocity is dx by dt, correct or not? That is infinitesimal displacement dx divided by dt. That is infinitesimal time interval, correct? Okay. This you can alternatively write as dx is equal to v dt. Understood? This we can write as dx equal to v dt. Fine? Yes or no? Now this dx I'm going to put it here. Right? This dx I'm going to put it here. So another way to write displacement would be as follows. Instead of dx, I put dx's value, that is v dt. But when we do that, the mathematical symbol changes a little bit. It's a rule, like I've said it earlier. If you write dt here, what we are really going to do is you are going to put the lower limit of t and the upper limit of t. Yes or no? Everyone got that? We are going to put lower limit of t and upper limit of t. So you should do this integration from initial to final. So just like that, if it's t here, then I will not write xi xf, I will write ti tf. Did you understand why I am writing ti here? Ti for initial time, tf for final time. Understood? Ti for initial time and tf for final time. Again, why are we putting limits of time here, not of position? Simple reason. Here it was dx, so you have to write limits of position. That is dt, so you have to write limits of time. Did you understand the meaning? This is actually the most general formula of displacement, and this formula is always true. It is true if acceleration is 0, it is true if acceleration is not 0, it is true if acceleration is constant, it is also true if acceleration is not constant. Right? This is always true. This formula is always true. Just like this is always true. Yes or no? Both of these are always true. In fact, there are two ways to look at the same thing. There are two ways to look at the same thing. How so? Listen to what I am saying carefully. Do you remember integration and differentiation are reverse processes? Everyone does? Okay. So what does differentiation of position give? Velocity. Correct or not? Differentiation of position gives velocity. Then here we go reverse. Integration of velocity gives us position. But because we are putting limits, we don't just get one position, but we get final position minus initial position. But that's called displacement. Did you understand? Right? Because of that putting upper limit and lower limit. So actually what is happening is we are getting xf minus xi. But that xf minus xi is called displacement. That is delta. Understood? So again, hopefully you are seeing that these are just reverse. And differentiation करता है. So एनु बाजू integration करता तो x आ जाता है. But because of upper and lower limits, we get delta. Got it? Minus integration. Now, do you realize that this thing, the way I told you, what is integration? We take something, we divide it into tiny parts, and then we add all of that up. This whole process is called integration, right? And normally we use it when things are not simple. For example, if you want to just find out area of board, there is no need to do integration. But if you want to find some randomly shaped area like this, then you need to use integration. You need to. Okay, you won't have to do it because you are not studying maths. Okay, but still, I am going to explain the general procedure because that will help build up an idea of what integration gives or allows you to do. This is a complicated shape. So the plan is, you see, I am dividing it into infinitesimal parts, very small. So every part is approximately like a rectangle. So if I just find out area of all the individual tiny rectangles and add all those rectangles areas, then what do I get?
Shape
I get the total. Yes or no?
Yes.
That's exactly what integration allows you to do. Right? So we are going to do this now in the graph. Suppose we have got a meeting. Let's say we have got a meeting graph. And the shape of the graph is not very regular, or let's say it's something like this. Okay. And I want to find out what is the displacement of the particle between this time and this time. Okay. So this is, let's say, TF means final time, and this is TI means initial time. Okay. You understood what I have marked? This is the VT graph, means velocity time graph from here to here. I want to find out the displacement. I've already told you how we find it. How do we find it? Area between the graph and the axis. Is that clear? We find it by area between the graph and the axis. Okay?
Yes, sir. Yes.
Now, what shape is this area? Can you at least visualize what area we are talking about? This one here, right? Is it a rectangle?
No.
It's a weird shape, isn't it? Correct or not?
Yes.
So, how will I find that area? The answer is by integration. First of all, I will divide it into tiny parts. How have we? I'm just drawing one sample. What I do is I take very thin strips like this. How much thin? Infinitesimally thin. Can we see it if it's infinitesimal? No. So that's why I'm drawing it a little bit larger. So let's say this is a small time interval. See, left side of this is starting and right side of it is final. Initial and final. So this is a small time interval. How much? dt. Infinitesimal time interval dt. Clear or not clear?
Yes, sir.
And in this, what's the height of the rectangle? Do you realize it will be velocity at some point of time? For example, here, how much is the velocity? That's this. So, do you see a rectangle? You might be thinking, what about the top? Is the top flat? No. It won't be flat because there is a curve. Flat would be only when if it's a straight line or a horizontal line. Agreed?
Yes, sir.
But that's the beauty of infinite symbols. What do I mean? If you will take this, it's curved, if you will make a very big interval like this and try to call it dt, then we have a problem because this is curved. But do you realize that as this shrinks, becomes smaller and smaller and smaller, these 2 points will become so close to each other that their height becomes almost the same. So that's why when you take a big time interval, it doesn't look like a rectangle in fact. How to do it? But when you shrink that time interval and make it infinitesimal, then it will start looking like a rectangle because these 2 points will come very close to each other. Do you understand that?
Yes.
So that's the whole idea. So what is the area of this shaded rectangle? Can you tell me that? What's the width of that rectangle? dt. Yes or no?
Yes.
The tiny width is dt. What's the height of that rectangle?
V.
So what's the area of this rectangle?
V.
V into dt. Correct or not? That is the area of that rectangle. But we have seen it also over here that V into dt, what it means is a small displacement. Yes or no?
Yes.
If you multiply velocity with time interval, you get a small displacement. It is fine, that is dx. Fine. So this area is giving us a small displacement dx. In fact, infinitesimal displacement. Infinitesimal displacement. Okay. So if I take another little interval over here like this similarly, then if I find its area for this rectangle, then I'll get another small displacement. Correct or not?
Yes, sir.
So if I want to find all the displacement from initial time to final time, what should I do? Make so many such rectangles, isn't it?
Yes.
And add all the area.
Yes.
Yes or no?
Yes.
So if I make so many such rectangles, can you imagine what's going on? like this. So many, and I'll find all the areas. Small displacement, small displacement, small displacement. Add all the small displacement. We get the total displacement from initial to
Final.
I'm not gonna comment.
Yes. Yes.
Sure.
Yes.
One more thing to note here is that as we are adding areas, what is really getting added? Displacement. So this is the proof that when you take a area here like this is area. Agreed? Area is V into dt. If you take that area is actually displaced. This is the same thing. Area between graph and the axis, horizontal axis, gives us displacement. Area between the VT graph and the horizontal axis here gives us the displacement. Clear? So when you add all those areas, you are actually adding all the displacement. So if I want to find the total area from here to here to here to here all the way till here, then basically I should cut it into so many rectangles and add. So that whole process of finding area, total area would be as follows. Integration means addition. Hopefully you remember what I told you. So addition of all these tiny areas, that is nothing but integration of ddt. So that is how area between this graph and the horizontal axis from initial time to final time gives us the displacement. Right? Because every tiny area is a tiny displacement. Every rectangle that we are drawing gives us a small displacement. So if we add all the rectangles, we are getting the total displacement. Proof is clear?
Yes.
Okay? And horizontal axis. We have studied that earlier also, right? But at that time I didn't give you the proof because the proof requires integration. Right? Clear what we did here?
Yes.
Let's take this one step further. Our topic about VT graph and displacement. Like this, have you seen any other relation like this in physics so far? V equal to dx by dt. Is there any other relation similar to this? Which relation? A is equal to dv by dt. Yes or no?
Yes.
Have you seen that?
Yes.
Okay. So now we are going to explore the relation of acceleration and velocity. So A is dv vector by dt. Correct or not?
Yes.
Compare this with this. Now just like from here we got to this point. That is, this formula is in form of differentiation. And we converted it by doing all the steps to the form of integration. Similarly, can you tell me what I should write in the form of integration here? Watch this and then go over there and try to put similar quantities. Here, differentiation of position gives us velocity. Over there, differentiation of velocity gives us acceleration. Okay. Here, integration of velocity with dt, that is v dt is integration, gives us delta, displacement. So similarly, what should go in this box? Integration of a dt should give us delta v. Is that clear or not clear? Not v, but delta v. Who understood that? It's the same procedure actually, correct? If you compare this with this, you will realize what is an axis place? V. So here there, axis place we should have V. Got it? Similarly, what is that V's place in that formula? A. So here also in V's place we should have A. Now what about limits? If this is dt, if this is dt, then ti to tf, and velocity is the vector, so you can put that way. Understood? So this is again a pair of equations that is always true, right? Both of these. यदि कोई मने पूछे कि what is kinematics? तो चार equations हैं बस. Entire kinematics, entire field of kinematics is captured in these four equations. Which four? V is dx by dt, and delta x is integration of v dt from ti to t. And similarly, A is dv by dt and delta V is integration of A dt from Ti to Ti. But I'm going to everything that we have studied, constant acceleration, non-constant acceleration, graphs, slopes, they will be there. It's all related to these four equations. Equations of kinematics can also be derived from these equations. That's what we are going to do very soon. Any queries about that? One more. This formula, I've told you that this is what it looks like, and that's why area between which graph, VT graph and horizontal axis gives us displacement. Yes or no?
Yes.
Okay. Now based on that, I'm going to write a sentence which is related with these two relations. Okay. Based on that, I'm going to write a relation. Area, very important, between AT graph and horizontal axis is equal to, what do you think? Velocity. Average velocity. And average.
Change in velocity.
Okay, think about it carefully. Area, if it would be VT, okay, don't worry, you don't have to change anything. I'm going to write the same thing. Area between VT graph and horizontal axis gives us delta. Agreed or not?
Yes.
And that is what?
Displacement.
Change of position.
Position.
So instead of V, if I make it A here, then similarly what change should
Change.
Change of velocity. Do you understand?
Yes.
Okay. Area between AT graph and horizontal axis gives you delta V, that is change of velocity. Okay. In fact, as we wind up the theory of this topic, I want you to remember this idea that slope of tangent is always differentiation, that is dy by dx. Slope of tangent is always differentiation. What do I mean? Try to recollect. From a VT graph, how do you find acceleration?
Slope of tangent.
Why? Because acceleration is the differentiation of velocity. Slope of tangent is always related with differentiation. Did you understand? Yes or no? Similarly, from xt graph, how do we find velocity? Slope of tangent. Why? Same reason. Because slope of tangent is related with differentiation, and velocity is the differentiation of position. Velocity is the differentiation of position. V is dx by dt, isn't it? Velocity is the differentiation of position. I hope this is making sense to you. Then whenever someone says slope of tangent, always you should do differentiation. Got it? Can be example happen? One for VT graph. In VT graph, slope of tangent is acceleration because dv by dt is acceleration. In xt graph, slope of tangent is velocity because dx by dt is velocity. Understood?
Yes.
So here are the mundu. Area between graph and axis is always integration y dx. Area between graph and axis is always integration y dx. For example, if you are finding area between AT graph and horizontal axis, then that actually means you are finding integration of y. What's on the y-axis in AT graph? Suppose this is an AT graph. What's on the y-axis in AT graph? Acceleration. Yes or no?
Yes.
AT graph means on the y-axis we have acceleration. What's on the x-axis in AT graph? Time. Integration A dt is change of velocity. Agreed?
Yes.
So this is how you can always find the area between some graph and axis. It's integration of y dx, and you can always find slope of tangent. It will give dy by dx. Understood? This is true for all graphs. This is true for all the graphs. Whatever kind of graph you may draw, this will always be true. कोई suppose, I'm just trying to test whatever you have understood. Suppose we draw a TV graph, not VT graph. If we draw TV graph, means T is on y-axis and V is on x-axis, and we draw a graph, and suppose someone draws a tangent and finds its slope, then what will the slope of this graph be? What will the slope of this graph give? Will it give dv by dt? What is on y-axis here? T. And x-axis v. So what will the slope of this tangent give? T by dv. Understood? dt by dv means what? Is it acceleration? Is it? What did you say? dt by dv is 1 upon acceleration. Did you understand?
Yes.
Yes or no? dt by dv is 1 upon acceleration. dv by dt is acceleration. So dt by dv is 1 upon acceleration. Did you understand?
Yes.
So like this you can apply for whatever graph is given to you. Do we really need to study so much about graph? Yes. We might not use it immediately, but in the few more chapters to come, we will definitely be using all these concepts. Okay? Right? So this is a little box which I don't want you to forget. Alright? Any queries? Yes?
Integration of y
Okay. Suppose we have a VT graph. Then integration of v dt gives you displacement, correct? Which is nothing but area. This is nothing but area between graph and axis. Yeah. Okay. So what that means is, if you want to find the area between graph and axis, then you should do integration, correct? Sure. So that's what I've written. If you want to find area between graph and axis, then you should do integration. Integration of what? Whatever is on y-axis with dx. Means whatever is on x-axis. So for example here, what is on y-axis in VT graph? Velocity. And what is on x-axis? T. So v dt. At y's place what do we have? V. And at x's place what do we have? T. So v dt. Understood? So similarly, whatever is on y-axis and whatever is on x-axis, you put that appropriate quantity, and when you do integration, you will get area between graph and axis. Maths is chapter. But this maths or this kind of relation we use often in physics. Okay, alright? Fine. Now, let's derive the equations of kinematics. Now, एक काम करें बेटा, इधर sound करो. Am I raising this?
Yes.
Have we skipped any of the questions from the assignment? Have I told you that we'll do it after integration or something?
No.
This. So suppose velocity of a particle is given by t square minus 1 meter per second. If the particle is moving and its velocity is given by t square minus 1 meter per second. Okay. And I want you to find the following. Find displacement in time t equal to 1 second to t equal to 2 seconds. And second, is position of particles at t equal to 1 second means 5 meter. Find position at t equal to 2. Okay. Look at the first question. What do we have to find? Displacement. Okay. Now, is this? No, we are not going to solve that in that manner, but I just want you to understand why we are going to do what we are going to do. Okay. Why we are going to do what we are going to do. Look at this velocity. Is acceleration constant or not constant? જોઈને ખબર પડી જાય તો મેં પૂછો બરાબર ને ખબર પડી જાય yes this is velocity can you find acceleration from velocity's formula what's that v is equal to dv by dt why don't you do it tell me what is acceleration that's not necessary to solve this question I'm just trying to make you understand why we are going to do it that way alright fine chalo find out acceleration from t square minus 1 to the minus acceleration how much 2t yes or no
Yes.
sure
Yes.
okay because when you do differentiation this is just extra for your understanding okay it has nothing to do with the solution of this vector so a is equal to dv vector by dt so that's going to be differentiation of t square is 2t and 1's differentiation is 0 because 1 is a
Constant.
got that
Yes.
so this is 2 think about it is this acceleration constant acceleration or not a constant how do we decide what's the meaning of a constant what's the meaning of a constant stays the same or does not change with time correct or not
Yes.
if you change time's value t's value will acceleration remain the same or will it change change
Yes.
sure when t is 0 acceleration is
Zero.
when t is 1 acceleration is
2.
it changes so is acceleration constant
No.
can we use equations of kinematics
No.
but અત્યાર સુધીનું ભણેલું બધું પડી you understand what I'm saying so far we have only dealt with those cases where acceleration is constant so you cannot use equations of kinematics clear or not clear if we could use equation of kinematics then we would always do it like this isn't it delta is equal to v0 t plus how many squares find displacement easy you see why this doesn't work here why it doesn't work because acceleration is not constant so rather we should go to something that is always true even in such cases what's that the general formula of delta is what that delta is velocity is given from velocity we will find delta is integration of v from ti to dx understood
Yes.
હવે ખબર પડી કે એમાં શીખવું પડે કે ન સમજ પડી હજી when acceleration is not constant even equations of kinematics cannot help you બરાબર ને in that case if you want to find displacement that is how much a particle moves in some time you have to use integration chalo the value okay what is ti okay from 1 to 2 so that's why it's suitable that we take ti as 1 and t2 as I mean t final as 2 clear or not
Yes.
initial time 1 second final time 2 seconds okay what's v then
T square
t square minus 1 okay again I think I did mention that you cannot put the values before doing integration just like you cannot do differentiation before putting values we cannot put values before doing differentiation similarly you can't put values before doing integration follow integration t square integration is by 3 okay and then minus 1 integration 0 yeah 0 check the rules out हाँ सीधे t yes भूल गया integration 1 dt is t okay let me write the step that will help you see first step which rule to use so t square dt is integration minus 1 dt is integration yes or no from 1 to 2 from 1 to 2 okay what is t square dt is integration t cubed by 3 that you did very well and then limits 1 and 2 minus over here what is integration of 1 dt or dt okay how do you use it from 1 to 2 okay so do it what will be the next step pull do it pull it લખો First you will go upper limit, now put minus sign and then you go x. Completed? Nice perfect. Minus? अरे बंदूक है. No, wrong. Okay. Okay. What happened? 2 Sure. So we are talking math no करें मैंने वो भी लगा के 7 minus 1 હોય તો અહીંયા 3 છે તો એક્સેપ્ટ ન લેવો પડે ધ્યાન રાખો done yes what's the answer you getting 4.3 unit kg unit meter what don't need to hide anything. Equal to delta x minus log Okay, 4/3 is what you are getting? Yes. 4/3 meter. Meter per second or meter? Displacement. What's the unit of displacement? Meter, right? So it will be 2 cube minus 1 cube upon 3 minus 2 minus 1. So that is 8 minus 1, 7. 7/3 minus 1. So that is 4/3 meter. That's the displacement. Got it?
Yes.
Okay. Next question. That's easy. Do it. એના માટે ઇન્ટિગ્રેશન ન કરવું પડે કરી દો. So what are we given? Position of particle at t equal to 1. Isn't t equal to 1 initial?
Yes.
T equal to 1 is initial. Yes or no?
Yes.
So this is initial position given to us. How much is initial position? 1. Initial position. 1 is initial time. Yes or no?
Yes.
Okay, then we have to find out position at t equal to 2 seconds. That is nothing but final position. Yes or no?
Yes.
Okay, we must go to group. Thank you. Okay, use the answer of first. Haven't we found something in the first? Then we go on to the group. Unit like that? Now we'll put together. Done?
Yes.
And the answer is 19/3 meter. Yes or no?
Yes.
What to confusion say તમારા માઇન્ડમાં? We want to find delta x. We want to find final position. Yes or no?
Yes.
And delta x is nothing but xf minus xi. Correct or not?
Yes.
Do we know xi?
Yes.
Given in the question?
Yes.
We have to find
Except.
the value and add. એટલે આવું જશે ને? So we go on. Okay or not okay?
Yes.
Final answer will be
19/3.
19/3 meter. Fine.
Yes.
I hope nobody has any confusion with that.
No.
Now let's try and derive the equations of time. I don't know whether we might finish it, but anyway, at least we get to 1, if not all the 3. that's some example from the book. I don't remember the number. I'm sorry. We are going to derive the equations of kinematics from these relations. Okay, and we have to use integration. The question for that example probably says use calculus. Calculus means differentiation, integration to prove the equations of kinematics. Now for equation of kinematics we have condition. It's only true if equation is constant. Please remember that. Okay, while we are solving this question. Now have a look at this. If we want to find out about velocity, we should start with this equation. So we'll start with. I'll write it. A is equal to dv by dt, and here everywhere acceleration is constant. So I'm going to multiply dt on that side, and I will write it as dv is equal to a dt. Did you get that?
Yes.
Okay or not okay?
Yes, sir.
Sure?
Yes.
Write dt on that side. Now we are going to do integration on both sides, left or integrating on both sides. Now see, whenever you want to do integration on both sides especially, you need to have infinitesimal quantities in numerator on both sides. Numerator समझ पड़े ना?
Yes.
Look at left side. This is dv. dv means infinitesimal change in velocity. On right side you have dt, means infinitesimal change in time. Then you can do integration on both sides. Suppose આ લઈને સીધો આમ કરો તો ન થાય. This is nonsense. Understood? Why can't we do it here? Because there is nothing like dx, dt, dv on this side. Did you get that?
Yes, sir.
કોઈ દિવસ ઇન્ટિગ્રેશન ની ફોર્મ્યુલા આમ ન હોય. આવું ન લખતા હો. Is this correct? બરાબર તો લખ્યું છે, નથી બરાબર? What is missing?
Yes.
Yeah, there has to be an infinitesimal if you want to do integration. Without that, it won't work. Clear or not clear?
Yes.
Okay. So, integration on both sides, we can do it now. So, I should write integration dv equal to integration of a dt. Time to put limit. Listen to this carefully. We are going to do this integration from t equal to let's say 0 when the velocity is v0. Initial क्या है? Okay, to final where at time t equal to t the velocity is v. A final velocity initial. Got it?
Yes.
Is this box clear?
Yes.
Remember, like when we are doing numericals, we always specify from this point to this point. So this is initial point, and that's the final. Okay. Now, time to do integration, and we have to put limits first. Sorry, I forgot that. Let's write down the limits. Initial time 0. So on this side, I should write limits of time. Yes or no?
Yes.
Upper limit final means t.
T.
Understood?
Yes.
Ti here. Initial time final. Got it? Okay, then left side final. Initial velocity and
Final velocity.
So
V0.
which limit will be v0? Upper or lower?
Lower.
Very good. v0 and v.
V.
Clear?
Yes.
Okay. Initial velocity, final velocity. There is another way, if you see that what you have done with time. So when time was 0, what was velocity v0? T અહીંયા આવશે. Similarly, when time was t, what was velocity v? અહીંયા આવશે. Got it?
Yes.
Okay. So now, what is integration of dv? What's integration of dv? V. Right or not?
Yes.
And then lower and upper limits to be put is equal to on the right side.
Delta A. V. Delta V.
If we will write down delta v on the right side, we will discover something which no one ever thought of. Yes or no? Yes or no? What will we discover? We will discover that v minus v0 is actually equal to v minus v0. એવું નહીં થાય? What is the meaning of delta v? V minus v0. Left side is v minus v0. Hooray! Achievement, isn't છે એટલે અચીવમેન્ટ જ કહે ને આવું તમારી સાથે 10th માં થતો હતો પ્રૂવ ધેટ ના સબમાં આડોડું કંઈ પણ કરો ને એટલે પાછું ઈ ને ઈ આવી જાય એવું થતું કે નહીં તમારી સાથે તો એવું થાય ઓકે સો ડોન્ટ રાઇટ ડેલ્ટા instead use some rule is a constant or not constant
Yes.
so what take the constant integration dt a integration dt from 0 to t now what is dt is integration
T.
put limit so upper minus lower so upper is
T.
minus
Zero.
understood
Yes.
on left side b minus b0 of course I have skipped a step આની વચ્ચે એક step આવે integration કરો એટલે t 0 to t okay but I think now you all are well versed with the basics એટલે હું નહીં લખું તો ચાલશે તમને તો આવડી જશે ને okay even if I don't write this step is it fine or not fine should I write it પછી કોઈને પછી ડાઉટ લાગે તો પૂછી દેજો okay no problem so here what have we got v minus v0 is equal to a into t t minus 0 is t correct or not
Yes.
so v equal to
V.
v equal to
V0 plus
are we getting the first thing understood what we did what happened some problem all came you with no समझ पड़ी no समझ पड़ी v equal to v0 plus at clear or not clear
Yes.
the first equation right I know you might be thinking what to do એના બદલે ઓલું કરવું I understand because you had that derivation in your 9th standard syllabus also એટલે easy to right but this is more so getting familiarized with how to do integration second one. Now we are going to try and derive second one. Now the second equation is about what displacement yes or no
Yes.
okay so displacement માટે અહીંયાથી start or directly from that formula delta x is equal to v dt is integration from 0 to t why 0 to t because initial time is 0 final time is t
T.
understood that
Yes.
formula like it in the use state well then what to do now integration of v will be v square by 2 will integration of v be v square by 2 no is v constant
Yes.
yeah no is velocity constant તો આટલી બધી મહેનત શું કામ કરી છે આપણે if velocity is constant acceleration is 0 તો આ બધું કઈ જરૂર જ નથી ને કઈ ખાસે જ નહીં ને v is v પતી ગયું you get what I am saying everyone velocity is not a constant clear everyone gets that
Yes.
okay. But you cannot do integration like this. Listen to this. Just like it is in differentiation formulas, you know, in integration also, this is not x cubed by 3. Did you understand? What's wrong here? What's wrong here? This is x squared, but then this is not dx.
Yes.
And there was problem. Although this is v raised to 1, but it is not v raised to 1 dv. So will the answer be v square by 2?
No.
So in integration actually the problem is more troubling. There is nothing like chain rule in integration first of all. Okay? Right? Directly you can say that તમે આમ કરો એટલે થઈ જશે. But we have similar methods. The idea is that if you convert this v to something of t, then we can do integration. If you convert v to something related to t, then we can do integration. Look at this. If we put v's formula, what's that? V equal to v0 plus at. Is that in the form of t?
Yes.
You understood what I'm saying?
Yes.
So that's the first step we are going to do. We'll put v's value from the first equation. So 0 to t, v0 plus at d. Raise your hand if you understood this step. That is what we have done. Now raise your hand if it is clear why we have done it. થોડું અઘરું બરાબર ને what we have done might be clear but why we have done it this way okay let me make it clear again If it was like this, then you cannot do integration because this is v and that is t. Both are variables, but they are different. So to make it same, what we are trying to do is we are trying to find a value of v where there is t. V equal to v0 plus t. Now the problem has been removed or eliminated. Now we can carry out integration further. Therefore, delta x is equal. Which rule to use on the right hand side? Addition. Correct? So what should I write? Integration of v0 dt plus integration of a dt. Don't forget that. Integration of a dt. Did you get that? Yes. Now we still have to write down limits. Don't forget them in any of the steps. Everyone, 0t, 0t. v0. Actually, it comes very. I think we have sufficient time to explain second term, not the first term. Sorry, space. Sorry. Here, something constant. What's constant?
Acceleration.
Put it up. Okay, t dt 0 to 2. Now, what is integration t dt? T square upon 2? Sure? We can use that formula? Because this is t and the dt, I mean that's also t. Correct or not? So it will be t square by 2. And then I have to put the square brackets and 0 and t. Yeah. Again, leave space for the first term. Okay? Is this fine? Yes. હવે લિમિટ મૂકવાની તો શું આવશે? a by 2 and then t square minus 0 square. Correct or not?
Yes.
I hope no one has any problem now with full putting the limits upper and lower. Everything is clear about that?
Yes.
Where you have to put, okay, in t's place. First of all, in t's place we put t. Then second time in t's place we put 0. Ask you half a t square. Which આવી ગઈ? Yes or no? Yes. We have got half a t square. Okay. Now I think the bell should ring any moment. Alright, that's why I'm not explaining this. But let's get on to that part. That is initial velocity. Correct or not?
Yes.
I am claiming that initial velocity is constant. I am claiming that initial velocity is constant. Who understood that? I have not explained anything yet. I am asking. Have you understood? Initial velocity is constant. Or in other words, initial velocity does not depend on time. Does initial velocity depend on time? No. No. Does it depend on time? No problem. It's a little tricky. Don't worry. Just